And I am going to introduce to everybody Dr. Peter Kolesar. Many of you know who Peter is. He is a longtime veteran of the Flexible Flow Management Program and one of the architects of that, and pays very close attention to it and in a very scientific way. And his work over the years has led to a lot of the improvements that we've seen in reservoir management, water releases, and flows in the Upper Delaware River. We obviously still have there's room for improvement, which I know Peter acknowledges, but he is one of the movers and shakers of how we got all the way to where we are right now. It wasn't a couple years ago, the Delaware River Basin Commission, at the behest of the conservation community, established something called the Subcommittee on Ecological Flows under the auspices of the Delaware River Basin Commission, and 4 folks who pay attention to Upper Delaware River management got appointed to that. I think I remember 5 folks actually: myself, Bob Bachman, Garth Pettinger, Jim Serio, and Peter Kolesar. One of the first undertakings, I think it was the first undertaking of that subcommittee, was to come up with 2 new protocols for the Upper Delaware River. And I just want people to know that this subcommittee is comprised of representatives from government at the state level and also the federal level, from all up and down the Delaware River watershed, from the Delaware Bay to the New York City watershed and everywhere in between. And I think it's pretty telling that the first conversation that this committee had was, let's do some things in the Upper Delaware River, particularly focused on Upper Delaware River wild trout fishery. I think that says something for how far we've come in some ways. That we had guys from the New Jersey DEP and Delaware government talking about Upper Delaware trout. And I think that's the way it has to be done, right? We're talking about watershed management. It has to be done on a holistic basis, right? We can't just think about our 78 miles of tailwater here exclusively. We have to connect all the dots up and down the river. And that's in part what this Subcommittee on Ecological Flows was doing when they came up with these 2 protocols. And one of them is Peter is going to give us a very thorough evaluation of and tell us how it's going. And that's called the Thermal Mitigation Protocol, which is a fancy and wonky term for let's keep the river cool to Lordville when it gets hot outside. Okay, so I hope that's fair, Peter.
But as cool as we can.
Cool as we can, right. So Peter is going to give us kind of how we got started on this, and then what happened all along the way, what we came up with, and how it's working. So with that, Peter, you have the floor here until 2:30. I hope we can leave some time for questions at the end. So go ahead, Peter.
Yes, and I'll have the ability to share my screen. Is that set up? Yeah, good. So I do just say a couple of words to get started. I very much intend there to be a discussion and conversation because these issues are important and some of them are controversial. Even within our own family, we don't all agree. So discussion time is important. I do have a lot of facts to get across to you. So I am going to skip over some things in my presentation in the knowledge that FUDR will post the whole thing. So you've got the document and you can go back and reflect on it. And then I just want to say thank you to Jeff for inviting me to do this. And it's nice to see old friends here, okay? And I need a word of explanation because Peter Kolesar doesn't look the way Peter Kolesar used to. In the second week of the Corona shutdown, all of my hair fell out. And so I became completely bald. And now it's growing back, but it's growing back erratically in kind of patches. I think I'm suffering another emotional crisis in the last few weeks I've been going through. So anyway, I'm still vertical, still taking nourishment, still fishing, heading for Montauk in the morning. So with that, let me get to the screen and to this presentation. Okay, and put this onto slideshow. And away we go, yeah. All right, so thermal mitigation experience, summers of 2019, 2020. The thermal mitigation program is included in theory in the FFMP 2017, but it wasn't until 2019 that it was first implemented. So my goal today is to go through with you in appropriate detail, I hope, what happened in those summers. And a little disclaimer, although I am a member of CEF, and I have shared a lot of this information with CEF members and the Delaware River Basin Commission, and I'm an FCDR member, these are my own views for better or for worse. A little introduction and background. I realize that there are folks here who know a lot about this subject, so, but you do need a little bit of setting the stage here. This is an old problem. I say a decade plus of struggle. None of the previous release policies, going back to the original policy, going back to revision 1, revision 7, etc., and the early versions of FFMP, none of those were adequate to protect the trout in the reach from Hancock to Lordville during summer heat waves. And we are well aware of that. And FUDR has been involved intimately in the struggle for at least a decade to get the FFMP, of which I was a co-designer, and which was really inadequate in the early years, to get it adjusted to deal with this situation. It's a pretty big deal. In the years from 2008 to 2018, the years of the FFMP up to present, there were at least 78 stress days, with one event lasting 12 days and one day reaching 81 degrees Fahrenheit. So it's a serious, serious issue to all of us concerned with the river, as most of you already know. Until 2017, FFMP, really until implemented in 2019, the decree parties declined, nice way to say it, refused to include a thermal mitigation procedure in the FFMP. Instead, every time something happened, it was a crisis, and we were all on the phone and emails, treating every instance as a real crisis. In that decade, my team at Columbia, colleagues at New York State DEC and Pennsylvania Fish and Boat Commission worked collaboratively, analytically, with data and statistics to show that thermal mitigation would be feasible in most circumstances, and that's where we are now. So here's what has happened. Under 2017, the decree parties established a bank of 2,500 CFS days of water to be expended at the discretion of New York State DEC by pulses of cold water from Cannonsville to try to keep Lordville daily maximum temperatures below 75 degrees Fahrenheit. That is the policy that has been established. And basically what I'm going to do with you this afternoon is not so much question that policy as to evaluate it. The bank size is curiously set at the beginning of the water year on June 1st and expires May 31st. So as some of you know now, we're dealing with a highly depleted bank, and that bank has to last us through the month of May. The use of the bank, these decisions are at the discretion of New York State DEC. Mr. Brennan Carrier is the guy mostly in charge, who has done quite an excellent job of dealing with a difficult problem in limited circumstances. We on CEF have offered advice, but it's Brennan's discretion to actually make the decisions. And as Jeff said, the DRBC Subcommittee on Ecological Flows has offered hopefully scientific guidelines on these protocols and the use of the bank. And I, Garth Pettinger, and Bob Bachman serving as an alternate, and Jim Serio are among the 13 CEF members. Other thermal metrics are of interest to many of you on the call here. For example, 2 successive days of the 75-degree max, a 68-degree daily max, a 72 daily average. These have all been considered by CEF and New York State DEC and are subject for further study and may be addressed in the future. Maybe we'll have some discussion of that at the end. Many of you have seen this map. Our focus is on the reach of river from Hancock to Lordville, where the metric is Lordville, the Lordville gauge, and the 75-degree max. But let's remember, the broad view was to make fishing for trout as good as possible in that reach from Hancock to Lordville. So it is the whole reach that is of concern to us, not just the Lordville gauge, and I'll be saying something about that. So what happened in 2019? There were 9 thermal relief requests made by Brennan and his colleagues at New York State DEC, and thermal releases were made over 17 days, using about 1,500 CFS days of water. This was a relatively easy, normal year. I grouped the releases into 6 thermal episodes. This is a little bit of some personal judgment on my part. Here's what happened. Largely a success. Lordville temperatures were kept below the 75-degree stress threshold, except for one day, July 30th, when it went modestly above 75.2. And I want to say, for those who are not involved in this, that Brennan, in implementing this program, is a guy like he was in a casino. We're dealing with the statistics of the weather and water temperatures, and we're dealing with some models that are imperfect. So it's not so easy to make a judgment to fine-tune your releases to exactly hit the target. I looked back. We had some theory that we've developed in Ceph, a statistical regression model, and I looked back with that model to see what would have happened had the thermal releases not been made. And my judgment is an additional 2 to 4 days would have been above the 75-degree limit, and that worst day, July 30th, would have been about a 0.2 degrees Fahrenheit higher. So it wouldn't, though the thermal relief program helped us, the situation would not have been terrible in that summer because it was not a tough summer. Okay. Although not an FFMP 2017 criteria, although Seth had discussed it, I thought it's also important to examine the 72-degree Fahrenheit daily average limit. And one of the reasons is that a 72-degree average limit was in prior rules like Revision 1 and Revision 7, and many fisheries biologists think that it is also an important criteria. So what I found is that generally, when the 75-degree daily max limit was met, so was a 72 daily average limit, except on one day. We'll come back to that a bit later. The story we're going to see is quite different in 2020, which is a much tougher year. Here's a graphic that I'll go by very quickly because you'll have FUDR post this. You can look at this graphic. Basically, the green line are the releases from Cannonsville as measured by the Stilesville gauge. The little bumps with the numbers are the thermal releases. And the blue line is the daily maximum temperature at Lloydville. We can see that it was kept, except for one day where my cursor is right now, that one day when it went very slightly above. This deserves some more study, but we'll take you a little more time. In our research, we have often used Fish's eddy as a kind of control gauge to compare Lloydville to. They run hand in hand to some extent, not exactly. And what you can see from this gauge, where what I've done now is added the Fish's eddy gauge here, you can see, if you look really carefully, that when thermal releases were made, again, the numbers show the thermal releases, that Lloydville is knocked down relative to Fish's eddy, which gives us another measure of the benefit that we are getting from the thermal release program. And what I did was I looked at the amount of that knockdown, basically the mitigation gain number in my table here, 1.03. This is in degrees centigrade. So basically during those days, when we were doing thermal mitigation, we have a gain relative to Fish's eddy of about 1 degree centigrade, which is about 1.8 degrees Fahrenheit. Similarly, now I said it's kind of important to look at the daily average temperatures. And as I said, and this graph illustrates, when you keep the daily maximums below 75, in this summer you kept the daily averages below 72. A very happy benefit. Thermal protection in the Hancock to Lloydville reach. So I add to this chart. So once again, I have the Lloydville daily maximums, and I add to this chart the Hancock daily maximums. I am interested in what happens in that reach, in that gap. And we can see that, I think a lot of us would like to see Hancock below 68. That's not written into the FFMP, but it's kind of a personal desire. And we can see in this chart that basically this program, which kept Lordville below 75, also simultaneously is keeping Hancock below 68. Another, I think, maybe fringe benefit of the program. So that's, I think, a pretty pleasant story. Now let's look at something that's going to be much grimmer. 2002, a tough, tough, tough summer. 22 thermal relief requests were made by Brian Tarrier and his team at NYSDEC. Thermal releases were made on 34 days using 2,350 CFS days. They used almost the entire bank. There's only a modest amount of water left in that bank today, which is going to have to protect us throughout all of May. I grouped the releases into 6 thermal episodes. Despite these releases, the 75 max limit at Lordville was exceeded on 11 days. Now I added here slightly in that it went 75.2, 75.3, etc. So it didn't go through the roof, but it did go above on 11 days, which is not good. The highest temperature was 76.3 on July 20th, and the 72 daily average, this is important, I think, for us all to remember, because it hasn't been given a lot of consideration in the past. That average was exceeded on 14 days. Had the thermal releases not been made, again, using my statistical regression theory, I estimate that the Lordville temperatures would have been exceeded on 15 days rather than 11, and by bigger amounts. You use degree days when looking at cooling and heating in your house to write the kind of degree day measure for the river, so we would have had 8 degree days rather than about 4 degree days. So this is tough experience, not exactly attractive experience. And it's hard always to evaluate what's going on, hard to reconcile all the files involved. On 2 of the days in which we had stress, directed releases were also made, which should have been to our benefit. Now, a little Monday morning quarterbacking by me. Again, using my model and imagining perfect forecasting, I imagine that the 11 stress days could have been avoided by releasing even more water than New York State DEC did. I estimated it would have taken another 760 CFS days of water to do that, which would have run us over the bank. Okay, and probably worse than that if given the fact that you do not have perfect forecasting. Okay, and the picture is grim. Look with me at the blue points above the red line. There are the 11 of them, and they happen despite the thermal releases. For example, look at my circle number 2. That's, I call it release episode 2. So we can see by the bump that DEC is releasing more water, but that bump is not sufficient to knock Lordville down to where it wants to be. And that is pretty much the story through much of that summer. We're getting the bumps and the releases, but the bumps were not quite adequate to give us the protection that we want. I again did a comparison relative to Fisher-Zeddy, a shortcut the conversation about now. Again, we are still getting a benefit. We are still getting a benefit. The benefit in the mitigation gain down at the bottom here, 1.45 degrees centigrade is the benefit that we have gotten. Okay. What about Hancock to Lordville? The story is, again, not quite as attractive. We weren't able to keep Lordville below 75, and we weren't even able to keep Hancock below 68. We can see the purple line is Hancock, and we see episodes in which the Hancock temperatures of the Hancock gauge, which is just above where the east and west branch come together, goes above 68. So this summer 2020 was a tough one by many metrics. Uh, and Also, similarly, and even more disturbing to me personally, is the fact that the Lordville daily averages also went above the 72 potential target there, and they went above that on 18 days. So we had 18 days when the daily average, so you're going to have hot water in that system for much of the day. And the issue isn't just the peak, which is happening 3 or 4 o'clock, 4 days in the afternoon. A few more words about that, because this has implications for not only our strategy, but our tactics in how we do thermal releases. Weather effects and trends. Just in summary here, I'll let you come back to this slide later at your leisure. Summer 2020, average daily maximum temperature at Binghamton, 82.3 degrees, way, way above the 20-year average, and even considerably above what happened in 2019. We're not just interested in those maximums, but the number of days over 80 degrees, because our research shows that it's going to get you in trouble in warm temperatures. July had a whopping 26 days over 80. And that this really is kind of explanation for why we had such a difficult time in 2020. Okay, what's happening? I'm seeing a little sign that says my internet connection is unstable. I hope that you're all able to see the slides and hear me. So I thought, let's take a look at the trend. Binghamton average summer daily maximum temperatures. This is June, July, and August. From 1960 up to 2020, there is a modest trend upward, which we would expect. I would have expected that trend to have been even stronger. I therefore also looked, slide here. Here's a slide. This is daily average temperatures throughout the year. So we have a pretty strong trend in the year annual temperatures, but fortunately for us, the summers don't seem to be quite as bad. Let's hope that continues. And I'm closing now. I'll just say that what is planned doesn't always happen. So, for example, on release number 2, which we saw in the graph, Brennan actually asked for the release to start at 4 o'clock in the afternoon, to run for 12 hours, and to be a jump of 50 CFS. The actual bump was 100 CFS and lasted a different time period. So, and what we see, I think Brennan is learning as he went and realizing he had to save water. As we go through and look at these things in detail, which I will not do with you this afternoon, but I've done a lot of, what you find is that Brennan, trying to save water, trying to artfully time the releases to hit the peak, makes the releases shorter. Rather than 12-hour releases, he's going to 8-hour releases and possibly less in the future. So that's a two-edged sword. It gives you a hit of getting cold water maybe exactly when you need it to hit the peak, knock the peak down, if you can get the timing just right. But it saves water, but it gives you the fact that you are not then controlling average temperatures as much as we might like. And there are a bunch of issues that this discussion raises. So one is perhaps reconsideration of the average temperature at Lordville exceeding 72 degrees is a criterion that perhaps should be reconsidered. There is the issue of the adequacy of the size of the bank. We just made it through in this year. That bank size is rather arbitrary and could possibly be subject to future negotiation. I mentioned Brennan's tactic of going to shorter pulses, and we see the pluses and minuses of that. So more research on that might be in order. The CEF team is doing some of the theoretical work, which I don't need to discuss with you this afternoon. And other members of CEF, as just mentioned, there are representatives from downriver. They are quite concerned whether a thermal mitigation protocol might be having negative impacts on shad or other warm water species, such as smallmouth bass. And there always is the question on a lot of people's minds of the feasibility of a more aggressive triggers, such as the 68-degree daily maximum at Lordville that many who are on this call have been advocating for many years. And that's it, guys. I hope I'm kind of on time and that we do have some time for questions and discussion.
Thank you, Peter. Yeah, I just, that last point, I just want to emphasize, and I think we do have some time. We do 12, and we're going, the next session doesn't start till 2:30, so I have a little bit of time. Thank you for allowing for that time. That last point you make about different lower temperature threshold, which I think is also related to the size of the thermal bank. You know, this has been the struggle for our community from the very beginning of this exercise, because we agreed in good faith to participate in the SEF discussion about the new thermal mitigation protocol, but many of us in the Upper Delaware River angling community felt like what we were handed from the start put us behind the 8 ball at the beginning, right? That we were given we were given a 2,500 CFS thermal bank, which for those of you who follow reservoir management and water quantities and volumes, you know that that's very, very small. And that's what drove the temperature target at Lordville to where it is in the current policy, which is max daily 75 daily maximum. So that's been difficult for us to wrestle with, because there's a lot of opinion about water, trout needing cooler water temperatures to thrive. So I'll leave it at that. And then Grant, are you there monitoring any hands for questions?
Yeah, I have one question, and it is from Steve Taggart.
Can you unmute Steve?
He should be able to unmute himself.
Okay.
Yeah, sorry, I know my audio stinks. I was going to have Grant read it for me, but I don't know if Peter, I didn't hear him explain a CFS day. Can you explain how that's calculated?
Yes, it is a cubic feet per second is a rate of discharge of water. And if you discharge at that rate for a day, you get a CFS day. Forgive me, but I do not remember. It's a CFS day is a certain number of millions of gallons of water. And forgive me, at the moment, I don't remember what that number is. But it is essentially, when they budgeted us 2,500 CFS days, they budgeted us a certain number of millions of gallons of water.
Thank you.
And Lee Hartman also has some questions.
There. Hi, Peter. A couple of questions. Number one, I like the idea of, this is not a question, but I like the idea of maintaining at 68. That possibly could get us through the summer at 72. But is there any consideration that we could replenish the bank should we get more water in the reservoir, and that way we can have it more stabilized bank of water?
Really, really great question, and a sore point with me personally, because I'm not a fan of this concept of the bank. The bank is a paper accounting, so it's a budget of a certain number of millions of gallons on June 1st, irrespective of how much water is in the reservoir. So I've said over and over again, sometimes in meetings with FUDR, but certainly with the decree parties, that all the water really is the water that's in the reservoir. So we could get to a situation, as we almost did now, in the end of August, the bank was essentially depleted, and we were in very good shape in the reservoir. There was plenty of water in the reservoir. So I have long thought that this concept of the bank is excessively rigid, and there really ought to be a way to replenish it. The only possibility for us at the moment under the current FFMP rules would be that we in the, say, in the fishing community would petition to the decree parties to make a special case of a special reallocation of water when the bank is depleted. But it's not a very satisfactory way to work in the future.
Yeah, now, the coming year, next year in May, you know, the reservoirs generally do fill up, and we could be in trouble if there's a hot month in May down in Lordville.
Yes, that's exactly right. Since the reservoirs often spill at that time of year, we could be in the weird situation that the bank will be empty, the reservoir will be spilling, and the rules say don't release water for thermal purposes,
Mm-hmm.
or close to spilling.
Yeah.
So Peter and Lee, I'll just add to that, so the situation we're in now, I don't know, Peter or Grant, do you have that number that's left in the bank? It's pretty small, right? It's like 100, maybe 117, something like that, or is it lower? In any case, there's not a lot left in the bank. We've got to get all the way to May 31st, right, of 2021. So the Subcommittee on Ecological Flows, and by the way, I misspoke earlier. I failed to mention Garth Pettendrew, I think, is on the call. He's the primary, and Bob is the alternate for Trout Unlimited. So sorry about that, Garth. That committee got together and said, what are we going to do if the bank runs out? A few months ago, talked about it. We said, okay, let's ask for more water just in case. And that request went in. And I think at the last RFAC meeting, I asked what was the status of that. And it sounded a little unclear to me. So the request went into the decree parties for an additional amount of water to supplement the current thermal bank. And I think the answer was something like, well, it's sort of on hold, and we're going to see what happens with the weather and the depletion of the bank, which to me sounded like worrisome. But I might have that. I mean, it sounded to me like we had to run out of the bank first before we decided on replenishing it. But I could be wrong about that. And I know there's some people on the call that are more closely associated with that decision and that process. And if they can feel free to correct me if I'm wrong, but that was kind of what I thought I heard at the last DRBC Regulated Flow Advisory Committee meeting.
Yes, I believe they put it on hold because for them it would be a difficult decision. You're realizing now that New Jersey, for example, thinks that the water in the reservoir belongs to them, and they are going to look very carefully at releasing more water from the upper Delaware. So it would be a political decision. My sense is they will avoid making that decision until they have to.
Okay, Grant, are there any other arms up in the air?
Nope, no one that I can see.
Okay. Well, thank you, Peter. Thank you. Unless you have any closing thoughts, we can probably take a quick 10-minute break here to our next session.
No, wait. I have a few hundred other slides I could show you.
I know you do. I know you. I do want to give the opportunity if you want to make any closing comments, and thank you for joining us. That was an excellent presentation.
No, thanks, guys.